In this video, I'm going to be solving the problem of finding the tension in each rope with its hanging mass. Here we have a 125 kilogram block hanging from two ropes, tension 1 and tension 2, at 60 degree and 40 degree angles from the x-axis plane. The first thing I'm going to do is put together a free body diagram for this model. We have the force of gravity, which is equal to mg. We have tension 1 in the x direction and tension 1 in the y direction when we break it down, and tension 2 in the x direction and tension 2 in the y direction. Dividing it like this makes it easier to solve the problem because we can split the diagonal force into two acting forces individually, and this helps us later with our sum of the forces equals 0 in the x and the y direction. The next thing I like to do is solve in terms of t1y and t1x and t2y and t2x. So let's go ahead and do that. All right, I have this set up here. And if you remember from geometry in high school, we know that t1y is opposite of our angle, which means that it's going to be sine of theta. So it's t1 sine of 60. t1x is going to be t1 cosine of 60 because it's adjacent to our angle. t2y is going to be t2 sine of 40. And similarly, t2 cosine of 40 for t2 in the x direction. The next thing I like to do is just turn these into decimals. It saves us a little bit of work down the road. And then we get t1 times 0.866, t1 times 0.5, t2 times 0.642, and t2 times 0.766. The next thing I like to do is write our summation equations. So the forces in the x direction equals 0. And we have two forces in the x direction, t2x and t1x. And it's going to come out to negative t1x plus t2x. t1x is negative because it's moving in the opposite direction of our coordinate system. Sum of the forces in y equals 0, which equals our negative force of gravity plus our t1y plus our t2y. The first thing we need to do is solve in terms of t1 or t2. In this example, I'm going to solve in terms of t2 and move forward with that. To do that, I'm going to bring our x equation down here and write t2x equals t1x. And from what we just discussed down here in the breakdown on the left side of the screen, we know that t2x is equal to t2 times 0.766, and t1x is equal to t1 times 0.5. Now if we solve for t2, we get t2 equals t1 times 0.5 over 0.766, which equals 0.653 times t1. I'll put t2 over here to make it more clear. And I'm going to circle that. The next thing I'm going to do is bring our y equation down. I'm going to move our force of gravity over to the outside of the equation to make it easier to read. And then we get t1y plus t2y in the vertical direction. Force of gravity is equal to mass times gravity, which is 125 kilograms times 9.81 meters per second squared, which is equal to our t1y and t2y. And like we just discussed before, our t1y is equal to t1 times 0.866, and t2y is equal to t2 times 0.642. All right, I'm going to multiply 125 kilograms times 9.81 meters per second squared, and that gives us 1,226.25 newtons is equal to our right side of the equation. And if you remember from before, we know that t2 is equal to t1 times 0.653, and I'm going to substitute that down here into this equation. Now we get t1 times 0.866 plus 0.653 t1 times 0.642. Now if we factor out the T1, we get 0.866 plus 0.653 times 0.642, and that gives us 0.419. And simplify once more, we get T1 times 1.285. Now solve for T1, and T1 is 954.11 newtons. From the same equation above, where we solved for T2, we know that 0.653 T1 equals T2. The T2 equals 0.653 times our T1, 954.11 newtons, which means that T2 equals 623.03 newtons. To check our work, since this is statics, the T2x needs to be equal and opposite to the T1x, and the summation of the T2y and the T1y should be equal to the force of gravity. We can check that by plugging our T1 and T2 into our initial equations that we came up with before. And as I finish plugging them in, we see that the T1x is equal to the T2x, which this is good, so that means our x direction looks good. And when I add together our T1y and our T2y, we get 1,226.16 newtons, which is very close to our original mg calculation of 1,226.25. These are likely just rounding errors as to why they don't line up perfectly. So this means that our T1 and our T2 are correct, and all of our work we did was also correct. I hope this helps. If you have any questions, please drop them down below, and I will get back to them as soon as possible.